Awesome. Hi, welcome everybody. We are here for our next session. It's complicated. I really can't say anything more than that, but hopefully our presenter can. Yeah, everybody give it up for Min.
Hello, everyone. Can you all hear me? Okay, perfect. Um, magandang umaga. My name is Ming, and I'm going to try to compress years of frustration into less than 20 minutes. Yeah, that does look frustrating, right? So why am I frustrated? Well, because language is such a key aspect of cultural heritage, but the current generation of digital maps is way behind in language support. So this is the map on OpenStreetMap's homepage, specifically one of the new layers powered by OSM vector tiles. If you haven't seen it, go check it out. The conference organizers invited me to give this language-focused talk because languages are so central to our international map-making community. In fact, unlike many commercial and government maps, OSM prioritizes the name of each feature in the local language and then more languages beyond that. Languages are even more important in a spin-off project, OpenHistoricalMap, which is starting to track the evolution of writing systems over time through changes in toponyms. Unfortunately, things are pretty broken in Southeast Asia, or so I'm told. So this is in Burmese. I don't know if you can see it, but it's mostly in Burmese, and there's like characters kind of all in a jumble. So under the hood, these maps are all powered by MapLibre, which is an open source library for rendering maps on the client side that started out as a fork of Mapbox GL JS and Mapbox GL native. So Mapbox did a lot of the early rendering, text rendering work, and it's kind of inherited by the MapLibre project. So let's break down what you're seeing on this map. This is again the vector layer on osm.org. So if you switch on, this is like a debugging option. If you switch on the label, the collision inspector, the overdraw inspector, each of the labels you see on the map consists of a separate glyph per character. So this is, I think was so this is the street name that the street that we're on, and each of the characters is a separate box there. So to render each glyph scalably, as you zoom in or rotate the map or whatever, MapLibre relies on a sign distance field font, so SDF fonts. And the way that works is it represents each glyph, think letter or whatever, as a series of vectors. Similar to like SVG and or other kinds of formats that have vector information. So if you're familiar with web or mobile development, actually using SDF fonts is actually pretty unusual. Most web pages and native applications rely on platform technologies to render text. You just hand the platform a string and it just does the rest. But maps have some interesting requirements beyond what the most obvious text APIs provide on the platform. So for example, most users expect road labels to curve along with the road. And so just as a point of comparison, an alternative open source library, Tangram, uses those platform APIs, but it's unable to curve text. So even though it's able to basically use any font that the system provides, it sort of has this scrapbook aesthetic, which is cool for some. This style, it kind of works. It looks like a kind of a sketch of some sort, but it's not quite as refined as a lot of styles need. So I'm going to kind of elide a bunch of low-level details about how MapLibre and Mapbox GL render text. For more information about the full pipeline, you can look at this. This is a really good write-up of the pipeline that's on GitHub. And so Oliver Whiffley did a lot of work to kind of understand the system and kind of push it in different directions. But I'm going to focus on a particular stage of the pipeline, which is text layout. So going back to languages, did you notice the cycle lanes on the street outside? The cycle lanes are marked in non-Latin text. So this is this word here is padyak. It means cyclist in Tagalog, but it's written in the Baybayin orthography. So it's an alternative orthography for Tagalog. So this word consists of four different graphemes. So I don't know if you've heard the word grapheme before. A grapheme is a cluster of characters that the language visually and logically treats as a single written unit. So for those of you, so since you're used to computers, think you're entering text in a text box, and you push the right arrow key to go advance further, right? And so each time it skips, that's one grapheme, essentially. So typically, a font assigns one glyph per grapheme because within that grapheme, there might be a lot of different variations in how the parts of that can be combined. To a naive computer, however, this same word here consists of 6 different characters. So you see here highlighted in yellow, that's, so there's 4 base characters and then 2 combining characters that are combining with the base characters. And in Unicode, each of these 6 characters is encoded as a separate code point, a distinct code point. So you see it broken down here. That's 6 Unicode code points. And so one of the longstanding assumptions that MapLibre makes, going back to the Mapbox days, is that a font is basically a set of code points, nothing more than that. So it doesn't really know anything about graphemes that kind of go at a higher level than that. And Yin is not alone among the writing systems of the world that feature this distinction between graphemes and code points. So if you look at this map here of the different writing systems, you kind of assume that the Latin alphabet, Cyrillic, is kind of covered. I mean, there are combining diacritics, but they're pretty rare in general in most languages. But when you get to the Middle East, when you get to Southeast Asia, things get a lot more complicated. And these are languages that historically haven't gotten a lot of attention in map rendering development. So I showed Yin because it's kind of relevant locally, but there's a lot of language, especially in the Indian peninsula, that Indian subcontinent, that have even more complex shaping rules. So a diacritic might go to the beginning of the word, it might change the look of several other characters in the same word, and so on, or might go the other direction as well. On native platforms, most applications that need custom text shaping would include the Harpfuzz library to handle all the complexity. And this comes from the Harpfuzz README, so they're well aware that as obscure as it is to lay people, it's used all over the place. But it's actually quite a large library, to the extent that it's not really realistic to convince web developers to bundle all of Harpfuzz as an optional dependency. So back in the day, Mapbox tried some different approaches to shaping the text on the server side. And one of, I think this is kind of one of the more humorous things that I found out about when I joined, which is that at one point they were trying to, so they're kind of creating the vector tile standard at the time, and they were experimenting with actually baking hints about how to render the text inside of the vector tiles. So you load the vector tiles, and that's self-contained. The problem with this is when, kind of the promise of vector tiles is that you can apply a multitude of style sheets to the same vector tiles without having to roll a separate set of vector tiles. And those style sheets, ideally, are able to pull in different fonts, different font sizes, different styles. And that's not really possible if you start hard coding very presentational hints inside the vector tiles. So instead, Mapbox wound up hard-coding English names in their styles by default, kind of papering over that issue, because everything else about vector tiles is great, right? And even in a case where maybe you enable the local language labels because you want to show something more international, Mapbox, across their pipeline, they would have sort of blacklists of writing systems that they knew would be problematic in the rendering pipeline. So this is sort of a pragmatic solution in anticipation of better writing system support that would come next year, eventually, right? And to some extent, vestiges of the solution are still present in MapLibre. On the other end of the spectrum, some writing systems like Chinese, Japanese, Korean, CJK, tend to have extremely simple text layout. So in general, you can get away with putting CJK text on a uniform grid. And that's actually stylistically usually what you want to do. On the other hand, typical CJK text involves such a variety of different characters that if you just consider the characters that are present in a given map view without panning around, that's a lot of different glyphs that if you download all of them at one time, that can be pretty costly. So this led Mapbox to develop a library called TinySDF that renders an individual character off screen somewhere, takes a screenshot of that character, and reports its dimensions and its SDF vector data and kind of combines that into this glyph atlas. So it's sort of takes that SDF font that would have been downloaded from the web and just cobbles it together based on what you happen to be viewing at a given time. This is imperfect, but it's usable enough for CJK text, and with some tweaks, it can also be used for some less uniform writing systems like Latin and Cyrillic. Another challenge with CJK text is that maps normally lay out text vertically to fit the allotted space, or to follow a line without requiring the user to cock their head to read it. So fortunately, MapLibre does have fairly decent vertical text support that inherit from Mapbox, but there are still some areas for improvement. So like, for example, conventionally, when you have just a few non-CJK characters inside of running CJK text, say a letter or a number, CJK, like the ring convention is to keep that upright and squeeze it into a character frame. And then if there's like maybe a pair of, so you see like the numbers, the double-digit numbers here. If there's a pair of those, you just squeeze it in. So Japanese call this tate chuyoko, and that'd be really nice to have on map labels. For example, the names of metro stations that tend to have numbers in them. So that's something that's not supported yet, but that would be very nice to have. Writing systems can also vary along the horizontal axis. So right-to-left languages, particularly in the Middle East, require flipping the character order before computing line breaks, but after handling any complex text shaping. So the canonical example here is Arabic, because it has complex text shaping, meaning different variant fonts, variant glyphs depending on where in the word it is. They combine into interesting ligatures, and it's right to left. So this affects not just the Arabic orthography, but also related orthographies like Persian, Urdu, and Kurdish. So MapLibre currently relies on a Mapbox plugin that mostly gets most of the way by transforming certain sequences of code points into pre-composed characters that we can depend on the font to provide. And this relies on an obscure section of the Unicode standard that only exists for compatibility with legacy systems, like DOS. I think some of you might be old enough to remember DOS. Okay, good. So back in the DOS days, merely supporting Arabic was a big deal. So this mechanism doesn't actually support other RTL scripts like Kurdish, Persian, and Urdu. It's really just for Arabic. It's also a huge lookup table, so that requires a lot of space. That again, it's hard to convince web developers, especially those who speak English, to add that kind of dependency. So MapLibre contributors are exploring several different approaches to solving these problems. One is to bundle TrueType fonts with HarpBuzz, as I mentioned earlier, that little peg that's holding up the world, and also have developers bundle TrueType fonts that they care about within their application. So this is impractical for the web, but it's a much better trade-off on mobile platforms. So MapLibre has integrated the solution on Android and iOS for those applications that are able to supply their own TrueType font. Another approach is to extend that tiny SDF mechanism, currently used for CJK text only, to support other writing systems, even emoji. So this would work across all the platforms with minimal code, with some gymnastics, but it doesn't solve everything that HarpBuzz does, because it's large because it's such a comprehensive library. So the dream is to be able to kind of have things both ways, to render any text as faithfully as possible, using as little custom software as possible, relying on the platform as much as possible. In order for this to work with complex text, well, at least the SDF mechanism, we'd have to rely on a relatively new web API called intel.segmenter. So you can see here, it's basically was introduced last year into browsers. And so that will tell us the boundaries between the different graphemes, like those 3 or 4 graphemes in the Babayin text, but and as opposed to the character boundaries. There are similar APIs on native platforms too. So this is actually a fairly feasible thing to do, and it gets us, in addition to proper text shaping, it gets us some more sophisticated line breaking around word boundaries. So you see here, the name of Saudi Arabia in Burmese is not line wrapped there. It is here, and so actually it's not dependent on there being spaces. It actually knows about dictionary words essentially, and it can also handle CSS fonts, and yes, even some minimal emoji support. So it's not perfect. Yeah, 5 minutes. Okay. It's not perfect. So this is an example. This is, I believe, well, this is definitely text, and I applied some letter spacing here, so you can see how a native platform renderer would deal with it. There's 3 graphemes. They're separated. They have a certain shape. But even before and after that SDF text segmentation approach, it still manages to get things wrong. So it's not perfect. Slightly more readable, but not quite there. So that's the current state of things. And MapLibre considers this to be running system support to be a priority. It's on the roadmap, but it does need people to take a look at it. And in particular, I'm working on so you saw a preview earlier. I'm working on taking the extended SDF approach, and there is a demo of that you can try out, and feedback is definitely encouraged. And if you just want to geek out about languages with me, I'm always happy to do that. Here's my contact information, and salamat. Thank you everyone for your time. We have time for questions? Yeah. Okay.
You're talking about cool things. People are going to ask you questions.
All right.
I'll borrow this for a minute. All right. So before we pass it over to Venulus, any questions from in the room? All right. We'll let you think about. Of course. All right. Love it. Thank you.
First off, big thanks to you, Min. Like, from the Indian community, we have seen over the years you have been dedicated on this particular problem, which impacts more than few billion people.
Yeah.
And at Mapbox, where I am, it made no business case because customers were not there, but really hoping the OSM Foundation can prioritize an issue like this. I'm curious to know how Google Maps solve this.
Yeah. That's a great question. So, I kind of glossed over some of the alternative approaches in this presentation where, you could basically, as long as you have that hinting information about like where the graphing boundaries are or what glyphs to use for a particular font, you can get pretty far. It's just a matter of ferrying that information along. And with Google, the advantage they have is that they control the stack end to end, right? They know exactly which font, when they're generating their tiles on the server side, they know exactly which fonts are going to be used. If they change their font, they're going to coordinate that. And in an open source environment, we're trying to be more flexible and allow much more variation, and that creates additional complexity. So that's what we're dealing with here.
That's a great answer. Thank you. All right, passing it over to Venulus for a question. How much should getting map labels right be the responsibility of OSM.org, in brackets, OSMF run, versus the responsibilities of local run chapter websites?
Ooh, I love that question. So you mentioned, the Indian community cares a lot about this issue, and I know that the Indian community also has been, also exploring this issue. A lot of people have been trying to make advances in text rendering. So I definitely don't want to make it seem like this is a top-down thing. This is very much a grassroots, effort because it impacts people at the very local level. To the extent that OSMF relies on MapLibre, I think MapLibre improvements are beneficial. They benefit the users. There is a case to be made for that. But the people involved with kind of running, say, the OSM website, aren't really the experts when it comes to map rendering. And so that's why we do require, we really need a cooperation, right, between the different people up and down the stack. Let's provide room for folks who are working on MapLibre, and also encourage people in local communities who have the technical knowledge and also the understanding of the languages to provide the resources that are needed for it. It requires everybody to pitch in. So the question is it only being addressed by MapLibre? And I did point out, I did include a screenshot of Tangram to show that even years ago, Tangram actually could handle native text rendering. So it could, in theory, handle all these issues. But with that trade-off of it can't curve text. And so that's just a really big bummer when you're rendering map labels. And so yeah, it's not, everybody sort of deals with this issue eventually. It's just, it's always competing with these other priorities design-wise that maps have.
Questions for the room? We have.
Yes.
Take this back there. So
all right.
Hey, Peter. So fun stories time. What is the most fascinating language quirk or like typing quirk you have encountered yet when dealing with all this stuff?
So I did include some screenshots from OpenHistoricalMap, right? And it turns out that the set of writing systems used throughout time includes some very interesting considerations that the computing community has only just begun to grapple with. So, for example, we've got a mapper in OpenHistoricalMap that has mapped the Mayan Empire, and the Mayan writing system is super complex. It's got color. Colors matter in that language. The different layout within the character, the rotation, all these things all matter. And there's no solution for that yet anywhere in the industry. So like we're resorting to some like workarounds of just like putting in a hint as to what the character would be. But that's there's definitely some room for improvement there. And I really look forward to chatting with people on the Unicode side of things to see what their solutions will be.
So we've got an interesting question on the venue list. How does it handle vertical local scripts? For example, some Mongolian scripts.
That's a great question. So, so far, a lot of these different writing system considerations are being tested and addressed in isolation, right? So, when people work on right-to-left text, they're not really necessarily thinking about vertical text. When they're thinking about complex text shape, you're not thinking about the other two. And Mongolian combines all of those, of course, because of course there's always an instance of that. I don't think it handles it very well yet. This needs more testing. And I should also say that some of the current approaches rely on, well, we use this API that's supposed to do the right thing, but we found some cases where it doesn't, so we still have to hack around it anyways. So the example I gave at the very beginning involves a type of diacritic called a virama. And a lot of languages in Southeast Asia and South Asia have that. And I'm having to hard code, certain viramas that are used in certain languages because the APIs don't really deal with that yet.
Anyone else in the room with a question? We can keep on with the venue list because we've still got a couple in there. So next one, which countries / languages are being prioritized for this?
So I think ideally, all of them, right? Realistically, the priority is going to be on the languages that are very, very visible on the world map. So if you look at OpenStreetMap, on a map that's not localized into your preferred language, that has all the local languages everywhere, there's going to be certain languages that are showing up. And this is where it actually gets complex because, in OSM, the convention in India, for example, is to just use English as the local language, regardless of what's maybe spoken, locally, like hyper locally. And so there is some like, and I showed the example of Babayin, but like looking around OSM in the Philippines, there's very little Babayin because that's not really the normal or the most common writing system right now for Tagalog. So I think there's kind of another tier of these languages that don't show up right away, but that designers might want to expose later on. And maybe in OpenHistoricalMap also, right? Like that's another tier of like such a long tail of different writing systems.
All right, call for one short question before we close it out. Looking for once, and twice, argument for neighbor.
All right, thank you everyone.